Hello and welcome back to the BCRC Fusion 360 tutorial for beginners. I cut off the playback last time because the video was too long, so here is part 2. Now why don't we actually go ahead and add those screws into our model. So where do we find screws and how do we make screws? Because I don't really want to design a screw. The cool thing is we can go to a website called McMaster-Carr, which is where we buy most of our hardware components. So back on your browser, search up mcmaster.com, and in here, it's heaven for engineers. That's one way to put it. It's everything you want, anything you want, and it'll be delivered really quickly. Only problem is that it is a bit more expensive in some respects than other websites, but it is also super reliable. So in the search, I can search for plastite screws. We're going to use screws that are self-tapping, that drill into plastic specifically, so that it creates its own thread. We don't have to make a thread for it or use a lock nut. I'm going to search up plastite screw. Bam. It's going to be a number 6 because that's a good size for us. For the length, we already have 3/8 inch plastite. So down here, I'm going to click 3/8 inch for the length. And Torx or Torx Plus is obviously the best screw type. The problem with Phillips heads are that they are torque limiting, which means your screwdriver will just slip. And we don't really want that. And I want it as a rounded head, just for simplicity. So this is the screw that I want. So I can control click on that to show some more information about the screw. Up here in the URL, I'm going to go up here and select that type, that model number, to import it into the CAD. If you go back to Fusion 360, in the Insert drop-down, you can see Insert McMaster-Carr component. Thankfully, Fusion has an integration, so what we can do is maybe make this a bit bigger, and in the search bar, paste that over here. So you can download the step file. Make sure you're not on 3D SolidWorks, make sure you're on 3D Step. And you can download that and it'll automatically import it right into your CAD. Oops. This is much easier than downloading it from here and then uploading it back to Fusion 360, which we will have to do later for some components, motors and other stuff, which aren't on McMaster. Right, so now I can move this into place, and now it is a component, not a body. So bodies are different in the way that you can't just drag them and move them around, but you can move around components. So let's make this aligned up to there. Now there's the move tool, which is M for move tool, or it's down here, move copy. What I can do is select this, and I can use that to move this around, move this object around. I can use that on bodies as well. But a better way to do that is to use the joint tool. Say if this hole moves, if I go back into the sketch and change how far it is, that screw will move with it. With the move tool, it will not. So in Assemble, there's the joint tool. So I'm going to click on the joint tool, click on one selection over here, just this bottom circle part. I'm going to go back and click on one of these holes right here. And it's going to automatically animate right into there, into that portion. Perfect. Up here, it'll create a new folder. If you don't like this weird icon, you can hide that, which I like to do. And I'm going to go ahead and joint all the other screws. So maybe we'll fast forward. Maybe me in editing will fast forward if I remember to. Just click on J for joint, and you can joint that to this. By the way, I'm using Control-C and Control-V to copy and paste these components, if you're wondering. And don't forget to do the bottom as well. And you'll probably get an upside down joint with this one. Yep, and you can just click on that flip to flip it right back over. Whew, that took a while. But anyway, I'm back here and we have all these screws nice and aligned. So if I go back into the sketch and say I want to make this 1.75 instead, all these screws will move with it. Now let's revisit that fillet tool because I love it. Anyway, go back here and select this pointy portion, fill that back to 1/4 of an inch. I'm going to click that plus, add selection set, and we'll fill these outer corners. It's not as important to fill outer corners as opposed to internal corners. Outer corners are like obtuse angles, and inner corners are acute angles, or like internal, external. You can probably understand what I mean. But it's nice because it looks a lot better, and it's less sharp. And you can also add another selection set and do this 3D printed portion as well while I'm at it. And do a 1/16 of an inch fillet. Nice, it's already looking a lot better. And just before we leave, I want to talk about one last thing, which is importing other external non-McMaster components into Fusion 360. Now I'm assuming all of you guys are using N20 motors, so I can go back to my browser and search up N20 motor CAD. And in here you can find an N20 motor CAD. It's either in GrabCAD, which is a really good resource, right here, or in the Autodesk community itself, which is the company that makes Fusion. But I think the other model is a bit better, so go over here and I'll click download files. So just you can create an account and just download this step file. Make sure it's a step file. So back in Fusion 360 you can go to File, Open. I click Open from my computer and you can select that step file, and it will open it in a new design for you. So I can save that as N20 in my folder. And I can, so now it's a separate folder, right? It's a separate item, or separate, item, not folder. And it's quite simple to add it to this design. I can just drag it and place it. I don't know how it duplicated right there. That's kind of weird. But yeah. Now it's a motor that I can drop and drag in place. So now what I would recommend you do is create a motor mount right here that clamps it from the top and the bottom. Cool. There's one more thing that I have to show you. And for that, let's add a weapon motor to this robot. So the weapon motor that everybody should be using, it's quite a decent size and power for 1 pound bots, is the 2822 motor. So if I search on Google 2822 motor CAD, I can find a bunch of them here. And I want the one by Julian Mott. If it's not Julian Mott, don't do it, because there are some with completely incorrect dimensions. I used the one with wrong dimensions and I had to redo my entire CAD. So anyway, go over here, then download the files. If you don't know how to unzip files, just right click, extract all, extract, delete that folder, go in here, and then there is your file. I want to use this file, the .step file. Or actually the F3D will work as well. F3D is probably better. So I can go up here, click open, open from my computer, in here, and the F3D file. And bam, here it is. Cool. It's all jointed and nice, so I can hide those joints and save it in this file, in this folder. Should have renamed it, but whatever. Go back over here and I can drag and drop to place the motor. Now how do I mount this motor? I want to put this motor somewhere in the middle, like it is on Mobilizer. So I can use the move tool, just drag it wherever I want to. And now how do I make sure it's in the center? First of all, it's sideways, and it's not in the right place. So two ways I can do that. Click M for the move tool, and I can use a freeform move to rotate it any way and move it any direction, but I still won't ever get it in the center perfectly. But remember that joint tool, it has more uses, so I can click J for the joint tool, click on the bottom of that, and this curvature right there, and there you go. It's on there. But this isn't the correct place. I should probably move it back a lot more. So over here I can use these arrows to adjust it. So I want it to be 2.5 inches back. I can do that. Now this robot should be a lot taller, seeing how this motor doesn't even fit. But I'll fix that later. But the reason I added this motor is to introduce you to another tool called the projection tool. So let me create a sketch here, because I want to mount this motor, right? On the bottom it has 4 mounting holes, 1, 2, 3, and 4. And those are M3 screws that can thread into that. But how do I know where those screws are and where to place them on my normal CAD? That's where the projection tool comes into play. So if I go over here, the first thing I want to do is project the plane. If you are going to make any dimensions off of this plane, referencing any other lines, you definitely want to use to project the body that you've created a sketch on, because you can create sketches on any face that you want to. Anyway, let's go back to this bottom plate, and I can hide that, and I can click P for the projection tool again and select this, and I can click OK, and there you go. I have all 4 holes listed right here that I can use to project, or that I can use for the hole tool. So I can click Finish Sketch on the top, unhide the bottom panel, and then use the hole tool, select, oh, not those ones, these ones, the smaller ones. I can flip it around. And objects to cut, I just want to make sure it's the bottom panel. And over here, it's a clearance hole. I want it to be a metric screw. And then it's an M3. The bigger the number, the bigger the screw. And okay, there you go. I now have this. If you want, you can go to McMaster, find an M3 screw, and add it to the CAD, just like we did with these other screws. The final thing I want to tell you is, or teach you, is how to check weights. Your robot is a 1 pound robot, and it has to be 1 pound for it to be legal to fight. But how would I know how heavy it is? Now these motors, you can search it up, they'll give you weights of the motors, but how about these custom components that you made? Like this panel, this panel, this panel. Well, Fusion gives us the ability to check the weight of something. So I can right click something and click Properties, and there you go, it gives me the mass. But the physical material is steel right here, and the top and bottom panels are not going to be made out of steel. Might be aluminum, but it's not steel. So I can click Cancel, and let's make it, say, aluminum. Let's say it's going to be aluminum. I can right click on that, click on Physical Material right here to check a pattern, and I'll pull up a new panel over here. There you go. I already have the metal folder open, but you can open that. And we use 6061 aluminum, so I can scroll down here and click 6061. You can just drag and drop those. Boom. Nice. And now if I right click, click Properties, there you go, it's 3 ounces. And you can make a spreadsheet. I think I have a link that I'll give you somewhere, so keep an eye out for that. And with that, you can add all these materials and all these parts onto your spreadsheet, and you can keep track of exactly how much your bot weighs. Keep in mind that there will be discrepancies, and it's not going to be exact with all the wires and electronics and such, so don't count on this too much. If you're going to make a 3D printed component and you want to weigh it, do not use Fusion 360. Export that as an STL put it into a slicer and slice it. Prusa slicer is really accurate with weights, so it'll tell you exactly how heavy it is. Yeah, that should be coming up in an upcoming tutorial or in-person lecture for the BCRC. And I can press Ctrl S to save, and I can save it. You've seen how to create a simple robot like this, but how about we look at previous robots and then see how those are built. Let's look at Morebrizer first. So this is Morebrizer. I've referenced it throughout this tutorial series. And let's walk through how Morebrizer works. So in the back I have this 3D printed black piece right here. It's theoretically going to be made out of TPU, but in your case it can be made out of PLA, just as a prototype. On top here is a polycarb panel on the bottom and the top, along with a carbon fiber frontal structure, which is pocketed to save weight. We have two 3D printed portions, which are held top and bottom by these same Fostite screws, but these two are squeezed together and keep the motor intact and in place using these hex head socket screws over here. For wheels, we have Fingertech twist hubs with Fingertech foam wheels, and everything is held together by 3D printed parts. I can press V to hide an element, and over here you can see that there's a 3D printed central section, which this part right here, which holds the internals of the robot together and keeps the electronics away from the motor. Because funny thing about this motor, this is an outrunner motor, so this entire thing right here spins. That entire thing spins, so you don't want anything touching it. On here we have a pulley mounted. There should be screws. There it is. There we go, we have screws on this pulley. And if you look over here, this motor has a M2 mounting pattern right here, so you can stick screws in. And then we have a belt connecting to this pulley over here, which is holding the weapon through more of these M3 socket bolts. As for the bearings, we have a spacer, a bronze bearing, a thrust bronze bearing, also called an oilite bearing, an oilite spacer right there, and another thrust bearing right there along with the spacer. And we'll talk to you about how weapon stack-ups will work as well. Another thing I want to add is this is all held together by a shoulder bolt and a lock nut on top. Over here is our Fingertech it's a Just Cause Robotics switch, which has two terminals, one over there, one over there. You put the battery in one side, you solder the battery to one side, and your output terminal to the other side. And whenever you screw this screw in, it will enable the current, turning your robot on. Then it can be mounted by these two M3 screws, or through bolts right here. Have a screw and then a nut on the other side. You don't want a normal switch like normal appliances, because that'll get flipped off during a match. Trust me, it's happened to us before. And maybe you can see my first robot. It's really not very good. As you can see in this timeline, there's a million errors, warnings, and all that kind of stuff. This isn't a robot to reference yours off of, but I can show you the basis of how the type of vertical spinner robot works in this way. Over here I have 3D printed portions, 3D printed walls, which could be made into HMW with aluminum panels on top, but those aluminum panels never came into fruition because I didn't have enough weight for it. So this is my first robot, once again, so do not base yours off of this. Inside I have CADs of all the electronics, and these two motor mounts. These two motor mounts, and these are held in from the bottom by plastite screws, so this also works. The bottom is theoretically CF, but it only ever became wood. Over here I have a motor which has been press fitted, or the 3D printed section has been press fitted onto the motor. So by friction, it's been pushed onto the motor hub, so it'll turn with the motor hub. This isn't a very good idea in heavier weights, but for a 1 pound bot, it'll work fine. And on the other side of a shoulder bolt, a bearing on the wall, and a lock nut inside here. This means that this entire shoulder bolt rotates when your weapon rotates, so it's a live axle, where other robots were dead axles. And this is a steel weapon. Also a few other 3D printed components, like this motor protector and this wedge down bottom. Oh boy, this is bringing back really old memories. I also have these Polulu wheels, quite small, but they work pretty well. Okay, hopefully this tutorial has helped you learn a bit more about Fusion 360, and maybe you can evolve your CAD a bit more from now. If you have any questions, do not be afraid to ask me or anyone else. Right, I think this is the last ant weight tutorial video, so we'll see you next semester for the beetle weight tutorial videos, when we'll teach you a new concept called master sketching. Stay tuned for that. See ya!